In today's video, we will start with the question 6. The graph shows the cumulative frequency curves of the daily traveling expenses of 800 students in the two schools A and B. Now in the part 1, use the graph to estimate the median traveling expenses of the student from in the part A, school A, and in the part B, school B. First, we have to understand the scale along x-axis and y-axis. So the scale along x-axis can be find out by subtracting the first 2 points scaled along x-axis, that or 20 minus 0 divided by total number of squares between these 2 points, and though that are 10, so 20 divided by 10 is equals to 2. Now along x-axis, the scale along y-axis is equals to 200 minus 0 divided by 10, and it will be equals to 200 and divided by 10, and 0 cancel out with 0, so it is equals to 20. So each square unit along x-axis is equals to 2, and each square unit along y-axis is equals to 20. Since n is equals to 800, so to estimate the median from a cumulative frequency curve, we find the position of the median by using n over 2. So n over 2 will be equals to 800 over 2. So here we have 2 to the 4, and it will be equals to 400. Now we will look at data values corresponding to the cumulative frequency of 400. So from 400 along y-axis, we will draw a horizontal line until it touches the curve. Since we want to find out the estimate of the median traveling expense of the student from school A, so that's why we are taking the value from 400 and draw a horizontal line until it touches the curve representing school A. Now from the point of intersection on the curve, we will draw a vertical line until it touches the x-axis. So from x-axis, since we know that each square unit along x-axis equals to 2, so 40, after 40 we have 42. So from the graph, median daily traveling expenses travel expenses is equals to 24 cents. Now for part 2, estimate the interquartile range of the traveling expenses of the student from in the part A, school A. So from the graph, first we have to find out the lower quartiles and upper quartiles for the cumulative frequency curve representing the school A to find out the interquartile range. So since n is equals to 800, so to estimate the lower quartile from the cumulative frequency curve representing the school A, we find the position of the lower quartile by using n over 4. So n over 4 is equals to 800 over 4, and it will be equals to 200. Now from 200, we will draw a horizontal line until it touches the curve representing the school A. Now from the point of intersection on the curve, We will draw a horizontal line until it touches the x-axis. So here we have the value 30. So an estimate of the lower quartile is equals to Q1, and it will be equals to 30 cents. To estimate upper quartile from the cumulative frequency curve representing the school A, we find the position of the upper quartile using 3 by 4 multiplied by n. So here we have 3 by 4 multiplied by 800. Here we have 4. Here we have 200, and it will be equals to 600. So now we will look data values corresponding to the cumulative frequency of 600. So from 600 we will draw our horizontal line until it touches the curve representing the school A. Now from the point of intersection on the curve, we will draw a horizontal line until it touches the vertical line, until it touches the horizontal axis. So from horizontal axis we get the value. Here we have 50, 52, 54, and some about 56. So the value is 56. So the upper quartile is equals to Q3 is equals to 56 cents. Now since we have find out the estimates of the upper quartile and the lower quartile both, so we can find out the estimate of the interquartile range by using the formula Q3 minus Q1. So 56 minus 30 will give us the value 26 cents. So the interquartile range of the traveling expense of the student from school A is equals to 26 cents. Now in the part B, we have to find out the median travel expense of the students from the school B. So from 400 that we have already draw a horizontal line until it touches the curve school A. We extend this line, and from 400 we will draw a horizontal line until it touches the curve representing the school B. Now from the point of intersection on the curve representing school B, we will draw a horizontal line until it touches the x-axis. So since we know that a square unit along x-axis is equals to 2, so here we have the value 58. So from the graph, median daily travel expenses is equals to expenses is equals to 58 cents. Since we have already estimated the positions of the lower quartile and of the upper quartile from the curve A, now we have to find out the estimate of the lower quartile from the curve representing the from the cumulative frequency curve representing the school B. So from 200, we will extend the horizontal line to the curve B until it intersects the curve. Now from the point of intersection on the curve, we will draw a vertical line until it touches the horizontal axis. So here we have the value 40, 42, 44, 46 and 48. So values lie somewhere between 46 and 48, so it is round about 47. So the lower quartile from the graph is equals to Q1 is equals to 47 cents. Now for the upper quartile or the third quartile, we will extend the horizontal line from the point 600 to the cumulative frequency curve representing the school B. Now from the point of intersection on the curve, we will draw a vertical line until it intersects the horizontal axis. So here we have value 70 and 72 and estimated value is 71. So the upper quartile is equals to Q3 and it is equals to 71 cents. Estimated interquartile range of the traveling expense of the students from school B can be found out by Q3 minus Q1 is equals to 71 minus 50, 71 minus 47, and it will be equals to 24 cents. So the estimated dental quartile range of the traveling expense of the students from school B is equals to 24 cents. And the part 3, state with a reason whether the students from the school A or school B spend more on daily traveling expenses. So students from school B spend more on daily expenses, spend more on daily travel expenses. The median daily travel expenses is higher for school B than for school A. Since in the part 1 we have find out the medians for the school A and school B respectively, and those was 42 cents for school A and 58 cents for school B. So since the value of the estimated median for the school B is greater than the estimated value of median for the school A, so the school B spend more on daily travel expenses. Now for question 7, the graph shows the cumulative frequency curves of the amount of plastic waste in kg produced in 30 days by two factories P and Q. Along x-axis we have amount of plastic waste and along y-axis we have cumulative frequency, and we can see the two commuter frequency curve. The first curve representing factor P and the second curve representing the factor Q. Now in the part 1, use the graph to estimate the median amount of the plastic waste produced by factory P. So first we have to understand the scale along x-axis. Since we have 100 minus 0 divided by the number of squares between these 2 points, and that is 5. So 100 divided by 5 is equals to 20. So each square unit along x-axis is equals to 20. Now scale along y-axis. We have value 5 minus 0 divided by number of total squares between these 2 points, and that is 5. 5 over 5 gives us 1. So each square unit along y-axis equals to 1. Since here we have total frequency n is equals to 30. Now, to estimate the median from a commuter frequency curve representing the factory P, we find the precision of the median by using n over 2. So it will be equals to 30 over 2. And it will give us 2 ones are 2 and 2, 5 are 10. It is equals to 15. Now since we know that each square unit along x-axis is equals to 1, so from 15 we will draw a horizontal line until it intersects the curve representing the factory P. Now from the point of intersection on the curve, we will draw a vertical line. We will draw a vertical line until it touches the horizontal axis. So we have something here. Since we know that each square unit along x-axis is equals to 20, so we have 300, 320, 340, 360. Between 340 and 360, our values lies between these 2 points, so it is approximately 350. So the estimate of the median Q2, or the median amount of plastic waste, median amount of waste produced by factory P the graph, median amount of factory medium amount of plastic waste produced by factory P is equals to 350 kgs. Now for part 1b, we have to estimate the median amount of plastic produced by the factory Q. Now from 15 along y-axis, we will draw a horizontal line until it touches the commuter frequency curve representing the factory Q. Now from the point of intersection on the curve, we will draw a vertical line until it touches the horizontal axis. So here we have the value 500. So the median amount of plastic plastic waste produced by factory Q is equals to 500 kgs. Now to estimate the lower quartile from the cumulative frequency curve. To estimate the lower quartile from the cumulative frequency curve factory P, we find the position of the lower quartile from n over 4. So here we have for the part 2a n over 4, and in our case n is equal to 30, so we have 30 over 4, and it will be equals to 7.5. It is approximately equals to 8. Okay, since we know that each square unit is equals to 1 along y-axis, so from here we have 5, 6, 7, 8. From 8 we will draw a horizontal line until it touches the curve representing the factory P. Now from 8 we will, from the point of intersection on the curve, we will draw a horizontal line until it touches the x-axis. So here we have the value approximately 250, just because we know that each square unit along x-axis is equal to 20, so we have 200, 220, 240, 260. In between 240 and 260 we have 250. So the estimated value of the lower quartile Q1 is equals to 250 kgs. To estimate the upper quartile from the cumulative frequency representing factory P, we find the position of the upper quartile using 3 by 4 multiplied by n. So 3 by 4 multiplied by n is equals to 3 by 4 multiplied by 30, and it will be equals to 90 over 4. So here we have 4 2s are 8, and again 4 2s are 8, so 22 point. It will be equals to 22 point. It will approximately equals to 23. Now from 23 here we have 20, 21, 22, 23. Now from 23 we will draw a horizontal line until it touches the frequency curve, counter frequency curve representing the factory P, and from the point of intersection on the curve we will draw a horizontal line, vertical line until it cuts the x-axis. So here we have the value 420, just because each square unit along x-axis equals to 20, so we have 420. Q3 is equals to 420. Now to find out the interquartile range, estimated interquartile range. Of the amount of plastic waste produced by factory P is equals to Q3 minus Q1, and it will be equals to 420
minus 250, and it will be equals to 170 kg. So the interquartile range of the amount of plastic waste produced by factory P is equals to 170 kg. Now from 8, we will draw a horizontal line until it intersects the curve. Now from point of intersection on the curve, we will draw a vertical line from the point of intersection on the curve until it touches the x-axis or the horizontal axis. So here we have the value 320, 340, 360, 380. So the values lies between somewhere 360 and 380. So the value is round about approximately 370. So the estimated lower quartile Q1 is equals to 370 kgs. Now to estimate the upper quartile, we will look data value corresponding to the commutator frequency of 23 from the commutator frequency curve. So now from 23 we will extend a horizontal line until it intersects the commutator frequency curve representing the factory Q. From point of intersection on the curve we will draw a vertical line until it intersects the horizontal axis. So now here we have 500, 520, 540, 560. So this value is round about 560. So the upper quartile Q3 for the commutator frequency curve representing factor Q is equals to 560 kgs. Now to find an estimate of the interquartile range of the amount of plastic waste produced by factory Q can be found out by using the formula Q3 minus Q1, and these two values are estimated just because we have taken them from the cumulative frequency curve. So these values are actually estimates. So Q3 was 560 and Q1 was 370. So 560 minus 370 gives us 190 kgs. So an estimate of the interquartile range of the amount of plastic waste produced by factory Q is equals to 190 kgs. Now in the part 3, which factory P or Q produced more plastic waste? Explain. Factory Q produced more plastic waste. The median amount of plastic waste produced by factory Q was 500 kgs, which is much higher than the plastic waste of 350 kgs produced by factory P.